Greeting guys. So welcome back. So in this tutorial we'll be seeing step-by-step guide to deploy and test ML services on Kubernetes. So we will be doing a training of sentiment analysis model using Scikit-Learn, and we will try to deploy it with FastAPI-based REST API, and we will also do Kubernetes deployment with autoscaling, and we will integrate Prometheus monitoring, persistent storage for model artifacts. So this comprehensive tutorial walk through a complete MLOps project covering everything from local deployment to production deployment. So this project demonstrates a complete MLOps pipeline that includes model training, API development, containerization, orchestration, and monitoring. The system is built with a scalability, maintainability, and production readiness in mind. So let's dive in. So in our tutorial, we will be deploying a machine learning model serving API using Kubernetes. So if you're looking to build a scalable and efficient machine learning service, here we will be developing a sentiment analysis service. So let's break down the key components and just steps involved in this project. So basically we will be creating a sentiment analysis service that processes text input to determine its sentiment as positive or negative. So we will be using Kubernetes for container orchestration and ensuring our application is scalable and manageable. So additionally, we will integrate Prometheus for monitoring, allowing us to track the performance and the health of our service. So basically, if you see, the key components are backend API with FastAPI, and then machine learning model, and then containerization with Docker, and then orchestration with Kubernetes, and we will be doing monitoring with Prometheus. So we will be developing a high performance asynchronous API using FastAPI, which will handle incoming requests and interacts with our ML models. And then our sentiment analysis model will employ TF-IDF vectorization combined with logistic regression to classify text data efficiently. And then we will be ensuring the consistency across different environment. We will be containerizing our application using Docker. So this step packages our application and its dependencies into a portable container. And then we'll be using Kubernetes, which will manage the deployment, scaling, and operation of our containerized application, ensuring it can handle varying loads efficiently. And finally, we will be integrating the Prometheus to collect and store metrics, enabling us to monitor the application performance and then health in real time. So to getting started with this project, let me give a brief introduction about what is Kubernetes. Okay, so Kubernetes is an open source container orchestration platform that automates the deployment, scaling, and management of containerized applications. In the context of machine learning project, Kubernetes offers many advantages in terms of scalability and flexibility, and also in containerization, and do the automation and management, and also it just integrates with other ML tools, and then it just allows us to monitor and observe the model in real time, and then as for multi-cloud and a hybrid deployment by using Kubernetes. So Kubernetes enables horizontal scaling basically, so which are allowing the ML application to handle varying workloads efficiently. So this is particularly beneficial for ML models that require substantial computational resource during training and inference. And then Kubernetes can dynamically adjust the resources based on demands, and then ensuring the optimal performance overall. By containerizing the ML models and their dependencies, Kubernetes ensure consistency across different environment. And this approach, which simplifies the deployment process and reduces the works on my machine problem. We say it just works in my machine, but not in another machine. So as container encapsulates all the necessary components, so it will work in every environment. And then Kubernetes automates various aspects of application management, including load balancing, resource allocation, and health monitoring. So for ML projects, this means that models can be deployed, updated, and scaled with minimal manual intervention, streamlining the operational workflow. And then Kubernetes integrates seamlessly with various ML tools and frameworks. For instance, Kubeflow, an open source ML toolkit, which leverages like Kubernetes to provide a comprehensive platform for developing, deploying, and managing ML models. Kubeflow components like notebooks, pipelines, and K-serve, which enhance the ML workflow within a Kubernetes environment. And then Kubernetes supports like a integration with monitoring tools like Prometheus, so enabling the real-time tracking of application performance and resource utilization. So this is like really crucial for like machine learning project to ensure the models are like performing as expected and to identify the potential issues in the real time. And then Kubernetes is also cloud agnostic, okay, so allowing the machine learning application to be deployed across various cloud providers like GCP or AWS or Azure or on-premises environment as well. So this flexibility ensures that ML projects can leverage the best available resources and avoid vendor locks in. So this project, which implements a microservice-based architecture deployed on Kubernetes, as we saw, we will be containerizing our application components, and then we will be having horizontal scaling capabilities, and also we will automate the monitoring and alerting, and we will be using persistent storage management and configuration management through config maps, and then also service discovery and load balancing. So basically, what are the key features that we have added in our application? So the application is deployed with multiple replicas. Currently, we set to like 3, ensuring like continuous operations even if some instances fail. And also, we have integrated auto scaling. So Kubernetes Horizontal Pod Autoscaling, which is HPA, which automatically adjusts the number of pods based on resource utilization. And then monitoring, we have integrated the Prometheus monitoring for real-time metrics and observability. And we have the dedicated persistent storage ensures the data durability. And again, we have our internal service communication, which is managed through Kubernetes services. So regarding the technical stack, if you see, we have the container orchestration, which is Kubernetes, and monitoring Prometheus, and service discovery, which will be done with Kubernetes services, and configurations are managed with config map, and then storage is managed with Kubernetes persistent volumes. That's it. We are at the end of this first part, and thanks for showing interest in end-to-end tutorial on deploying a machine learning model on Kubernetes with auto scaling and monitoring. So in our next session, in your part 2 tutorial, we'll be seeing setting up the Podman or Docker and Kubernetes kind cluster, and we'll be configuring the Kubernetes environment and also verifying the cluster setup. So see you there.